In this video, we'll break down the concept of join queries and demonstrate how to use various types of joins in TDengine to efficiently retrieve and combine data from multiple tables. Whether you're new to joins or looking to refine your skills, this guide will provide clear examples and practical tips. Let's dive in. In join operations, the driving table is the one that is read first. After the driving table is processed, the data from the second table, the driven table, is matched with the driving table data. For left joins, the left table serves as the driving table, and for right joins, the right table is the driving table. It's typically best to choose the smaller table as the driving table to enhance query performance. The join condition specifies how rows from multiple tables should be matched. In TDengine, every join query requires a join condition to function properly. While we don't cover advanced topics like primary join conditions, grouping conditions, or primary key timelines here, you can find detailed information in the join section of our official documentation. Now, let's explore different types of join queries in TDengine with practical examples involving multiple power meters. An inner join returns only those rows where there is a match in both tables based on the join condition. Think of it as the intersection of the two tables' data. For example, to find moments when both tables of D1001 and D1002 have voltage readings exceeding 220, you would use the following SQL query. The output of this query is displayed on screen. TDengine supports inner joins across supertables, regular tables, subtables, and subqueries. An outer join includes all rows from one table and the matching rows from the other table. For a left outer join, it returns all rows from the left table and the matching rows from the right table. If no match is found in the right table, the result will be null for the right table's columns. For example, if we want to get all voltage readings from table D1001 and the corresponding readings from table D1002, where the voltage is above 220, the SQL query would be as follows. This left outer join will return all records from D1001 and any matching records from D1002. If no matches are found in D1002, the result will be null. The result of this query is shown on screen. TDengine supports left and right outer joins across supertables, regular tables, subtables, and subqueries. A semi-join is used to filter rows from one table based on whether there is any matching data in the other table. It's similar to using in or exists. For example, to find voltage values from table D1001 where there are corresponding values in table D1002 with the same timestamp and a voltage greater than 220, the SQL query would be as follows. The result of this query is displayed on screen. TDengine supports left and right semi-joins across supertables, regular tables, subtables, and subqueries. An anti-semi-join returns rows from one table where there are no matching rows in the other table. It's the opposite of a semi-join, similar to using not in or not exists. For example, if you want to find voltage readings from table D1001 where there are no corresponding readings in table D1002 with the same timestamp and voltage greater than 220, the SQL query would be as follows. The result of this query is shown on screen. Combining the results of a semi-join and an anti-semi-join will give you the equivalent of a normal left join. TDengine supports left and right anti-semi-joins across supertables, regular tables, subtables, and subqueries. An as-of join allows for approximate matching based on the closest timestamp, rather than requiring exact matches. For example, to find voltage values from table D1001 where the voltage is above 220, and also get the closest earlier timestamp in table D1002 with a voltage greater than 220, the SQL query would be as follows. The result of this query is displayed on screen. TDengine supports left and right as-of joins across supertables, regular tables, and subtables. A window join creates a window around each row's timestamp and performs the join based on this window. It allows for operations within the window, including projections, scalar operations, and aggregations. For example, to find voltage values from table D1003, where the voltage is above 220 volts, and also get the voltage values from table D1004 with a 1-second window before and after, the SQL query would be as follows. The result of this query is shown on screen. TDengine supports left and right window joins across supertables, regular tables, and subtables. A full outer join includes all records from both tables. For example, to query all recorded timestamps and voltage values from tables D1001 and D1002, the SQL query would be as follows. The result of this query is displayed on screen. TDengine supports full outer joins across supertables, regular tables, subtables, and subqueries. This video provided a basic overview of join queries in TDengine. For more detailed information on syntax and limitations, please refer to the official documentation.